All right, welcome to Curve Sketching Part 1. Today we're going to talk about how to graph these rational functions. First of all, the first thing you want to do is factor the numerator and the denominator. So this becomes x plus 2 and x minus 1. This becomes x plus 3 and x plus 1. If we could simplify, we would, but none of them there's not a common factor top and bottom. Then next we want to figure out what makes the denominator equal to 0, like the restrictions, because those are where we're going to put vertical asymptotes. And the two places are at -3 and -1. Then we're going to want to find the horizontal asymptote, and the horizontal asymptote is found by comparing the degree of the numerator and denominator. If the degrees are the same, then you're going to divide by the leading coefficients. And remember here, the degrees are the same because here it's a second degree, here's a second degree. Remember, highest power of x tells you the degree. So we divide the leading coefficients, which is 1 and 1, and we get that y equals 1. If the numerator is greater, there's no horizontal asymptote. If the degree of the numerator is less, then y equals 0 is the horizontal asymptote. We want to determine if the horizontal asymptote is crossed by setting the horizontal asymptote, the function, equal to that. So 1 is equal to x squared plus x minus 2 over x squared plus 4x plus 3. So then we're going to multiply here. And we get x squared plus 4x plus 3 equals x squared plus x minus 2. Notice the x squareds are going to cancel when we subtract. So right now we have 4x plus 3 equals x minus 2. We get 3x equals -5 and x equals -5/3. So at -5/3, comma 1, that is where the horizontal asymptote will get crossed. To find the x-intercepts, we're going to set the numerator equal to 0. So for the x-intercept, and that means we set x squared plus x minus 2 equals 0. We've already factored it to be +2 and -1. So that means x equals -2 and x equals 1 are the x-intercepts, which means it's -2, 0, and 1, 0. For the y-intercept, we're going to set x equal to 0. So it's 0 squared plus 0 minus 2. And then 0 squared plus 4 times 0 plus 3. So -2/3 is the y-intercept. So now we're going to graph the vertical asymptote, horizontal asymptote, and the x and y intercepts. So the vertical asymptotes are at -3 and -1. The horizontal asymptotes at y equals 1. The x and y intercept, the x-intercepts are at -2 and +1. The y-intercept's at -2/3, which is right here. So that means that the graph's going to look like this, because remember, the graph follows the asymptotes, gets close but never touches. The only place it's going to cross is at -5/3 and 1. -5/3 is here, 1 obviously is the asymptote there. So you put a dot, so that means it's going to cross and go up this way. And then down here it's going to continue down. So now we need to figure out what it does in this part here of the graph. And so we're going to choose an x-coordinate to the left of -3, so x equals -4, and we're going to put that in to the function. So we're going to go -4 squared plus -4 minus 2 over -4 squared plus 4 times -4 plus 3. Notice we get 16 minus 4, which is 12, minus 2, which is 10, and 16 minus 16 plus 3 is 3. So the point is -4 and 10/3, which means it's 3 and 1/3. So 1, 2, 3, and 1/3 right there. So it's going to follow the asymptote up that way and to the left there. And there is our full graph. All right, the next graph here, notice if we factor, we get x minus 2 and x plus 1. And here we get x minus 3 and x plus 1. Now notice we can cancel the x plus 1s. When we cancel out a factor, it creates a hole in the graph at x equals -1. And to figure out the y coordinate that goes with that hole, we put -1 in, and we get -3 over -4, so 3/4. So basically, at -1, 3/4, there is a hole, which means an open circle. There's a vertical asymptote at x equals 3, because that's still a restriction in the domain after we simplified. There's a horizontal asymptote at y equals 1 because the degrees are the same. They're both 2, and 1 over 1 is 1. So graphing this here, we get a hole at -1 and 3/4, which means it's right here. We get the horizontal asymptote of 1, the vertical asymptote of 3. Now the x-intercept, remember we set the numerator equal to 0, so x minus 2 equals 0, x equals 2, right there. The y-intercept, we put 0 in, so 0 minus 2 over 0 minus 3 gives us 2/3. And then look, so we know our graph is going to go like this. Towards the asymptotes in this direction. Now to see if it crosses the horizontal asymptote, we'll put the horizontal asymptote of 1 into the function x minus 2 over x minus 3. Notice when we multiply, we get x minus 3 equals x minus 2. And notice the x's cancel out, so we get -3 equals -2. That means there's no solution, meaning it never crosses the horizontal asymptote. So we know this graph, the horizontal asymptote will never be crossed. So now the only thing left to do is figure out what happens to the right of x equals 3. So we'll put in a point x equals 4 here. So 4 minus 2 over 4 minus 3. So we get 2 over 1. So that means the next point is 4, 2. So that means the graph goes like this. Because remember, it's never going to cross either the horizontal or vertical asymptote. All right, I hope you enjoyed the video and have a good weekend, and go Patriots.